Hey, hi everyone. So this is a question from the summer 2012 paper. So in this question, we are given a watermelon that is growing. So what happens is we are given the mass of the watermelon that will correspond with its radius in the form of big M equals to K, which is constant, multiplied by the radius cubed. We are also given that the watermelon actually grows at a rate of 0.1 centimeters per day. So the radius of the watermelon grows at that rate. So this question then asks us to find the rate of the mass increasing per day. So means that the mass per time. Okay, in order to do this question, first we establish what information that we have, which is mass equals to K, which is a constant, R cubed. Okay, so we'll know that the rate of change of mass with radius would be given by K 3R, 3 minus 1, so it will be 3R squared. We also know that the rate of change of the radius of the watermelon with time would be given by 0.1 centimeters per day. Okay, so with this information, I can actually use the chain rule. So noting that I actually want to find the rate of change of mass with time, I can actually attain it by doing the rate of change of mass with the radius of the watermelon, multiply the rate of change of the radius of the watermelon with time. Okay, and so therefore this actually gives me 3 kr squared multiplied by 0.1 or 0.3 kr squared. Okay, we are also given the information, so some initial information that when the mass is equals to 3.2 kgs, we know that the radius is 10 centimeters, so r is 10 centimeters. So based on this, I can actually find the value of k when I substitute it into the function of mass with relation to its radius. I actually have 3.2 equals to k 10 to the power of 3, and I actually get k as a function of 3.2 divided by 1000, meaning it's 0.0032 kgs per centimeter cube. Okay, so knowing this information, I can then get the rate of change of the mass with time, so the specific value, by substituting all the values in. So this becomes 0.3 times 0.0032 times r squared, which is going to be 10 squared. Okay, notice that I've not done any change in terms of the units. Centimeters I've not converted to meters because the consistency is there where the question only requires it to be in centimeters. So doing this multiplication, what I get is 0.096 kgs, and the unit for time is per day.